Now that we're done with the introduction, let us start off with this first chapter, Fuselage Geometry. If we want to build an aeroplane, we need to design the fuselage. It is highly important to know all requirements the aeroplane will need to be fulfilled. You must know what you are building your aeroplane for. Once you have done that and already did the first important calculation, you can start designing the fuselage. Fuselage serves to accommodate the payload. It consists of baggage, cargo, and passengers. The passengers are accommodated in cabin, cargo in cargo compartment, whereas smaller items carry-on baggages are stowed in the overhead storage compartment above the seats. Fuselage consists of cockpit and key aircraft systems. Fuselage longitudinal layout. The shape of the fuselage is assumed to be cylinder. Length of cylinder is equal to the length of the fuselage. Nose and tail section are smaller compared to the center section of the fuselage. Fuselage model is divided into nose, center, and tail. The starting radius of nose section is 20% of the input radius and it increases linearly. The whole center section is the input radius. The tail radius starts with the input radius and decreases to 20% of the input signal. The larger the fuselage, the more payload you can take, and this is at a high comfort. However, a smaller fuselage will also mean less drag. Remember, even though payload is the driving factor, you are still interested in other requirements such as range. The exact diameter and length of the fuselage will be our first dilemma. Since it causes 20 to 40% of the total zero drag coefficient, an increase of 10% in the diameter yields a 2% in drag increase. Fuselage cross-sectional layout. It shows the seating arrangement and the storage space below the passenger. It also shows the space for containers. Companies tend to build their aircraft in such a way that their sides are always a choice to the customer. This again shows how crucial it is to have a list of all requirements. These are some of the examples that are given. Once we have a rough idea about what we want from our fuselage, it's time to start designing. As said before, one starts the design from inside out. One notices that the design will need to focus on the seating arrangement, but also the storage space below the passenger. The space will contain the shape of the containers. When designing the cargo deck of fuselage, designers often use the standard container size that are widely used for airports all over the world. They are called LDs or load devices. These containers are standard because it is convenient with respect to the airport luggage transport management. Fuselage cross-sectional layout. Now let us first focus on all the seats and the spacings. These are indicated by parameters according to the aircraft's range. For longer range, the aircraft must guarantee higher level of comfort as well as more baggages. These are the different dimensions and list of the parameters: seat width, seat pitch, aisle width, aisle height, headroom, lavatories, galley volumes, baggage for long range and short range. These are the dimensions mentioned for a long-range aircraft and a short-range aircraft. As a rule of thumb, it is said that if the number of passengers is greater than 150, then install 2 aisles. If the number of passengers are greater than 500, then consider 2 decks. Fuselage cross-sectional layout. The contemporary transport aircraft fuselage is a skin structure supported by frames and stringers. The skin and the stiffening element carry the flight loads, including those due to cabin pressurizations. The stringers are joined by riveting, bonding, or spot welding directly to the skin. In order to connect the skin and the frames, 2 different solutions can be applied. One of these, addressed as the shear tied frames, involves attaching the frame directly to the skin shear straps. Another possibility is to connect the frames only to the stringers by means of stringer clips. Fuselage is designed with overlapping sheet metals riveting together called as lap joints. Fuselage layout. Usually the cross-section once fixed remains the same, but the length of the fuselage acts as a changing variable, which results in higher number of aircrafts, just like shown here with an example of A380. You might want to consider different shapes for the cross-section. Pressurized aircraft always tend to have circular cross-section, simply because it's the most effective shape that can hold pressure. But then again, not all airplanes are pressurized, and other requirements may be leading, such as comfort of passengers. Here are two examples that do not have circular cross-sections. Most passengers tend to have pressurized fuselage, reason of why there is so much research going on in creating a fuselage that is bigger, better, and faster. One idea is to have both fuselage and wing as one structure, but when observes the different design, it's obvious that the cylindrical elements are always basic. I hope you would have understood the fuselage geometry. Let us move on to fuselage structure in the next session. Thank you.